Everyone, this is Casual Dr. B. In the house, the Bridge for Math. Thank you for watching this video today. Another question on functions. Specifically, this topic, if you wanted to get even more information, is called the algebra of functions. Now, if you didn't have the algebra of numbers, now we're talking functions. Now, I have up here for you what you can do with numbers, you can do with functions. So think about it. What can you do with numbers? And please don't be mean and say shove them somewhere. Say with numbers, I can add them, I can multiply them, I can do all kinds of cool operations, divide them. That's what we're talking about, like what you can do with numbers, you can do with functions. As a matter of fact, if you think about it, you can take one easy function, add it to another function, and create a new function. So let's talk about the question for the day. The question here, we give you two different functions. The first function, f of x, is equal to 2x plus 6. That's a linear function. Right? Do you remember that the notation, f of x is the same thing as equal to y? So this is the same thing as saying y equals 2x plus 6. So that's a linear function. It looks like a line when you graph it. The function g, notice I have different names. This is the function g. G of x is equal to the square root of x minus 1. So this is a square root function. Two very different looking functions. Well, the question says if I have these two functions, find... Interesting notation here. It's f divided by g of x. So when you look at it, it's very confusing, but I'm just trying to share with you, once you get over the fear of the notation and recognize when you see the f and g like this, it's a function f divided by function g. This x tells you that's going to be your input for both of them. So another way of saying f divided by g of x is this, f of x divided by g of x. Now, don't get me wrong, you'd much rather see that, right? That would be intuitive, makes sense. Well, I apologize on behalf of all the crazy mathematicians out there. They gave this notation, so just know how to use it. The second part of the question is, find the domain of this new function. Now, that's important for you to understand, because if I asked you, what's the domain of function f of this line? Domain are the valid inputs, if you remember that, the valid x inputs. So if you drew a line that went forever and ever, what valid x inputs could you have? Yes, anything. All real numbers would be the domain of function f. Well, let's look at function g. What do you know about the domain of function g? Well, when it comes to domain, you just can't have negative totals into the square root if you want to stay in the real number system. So you have to make x minus 1, you have to make it positive or greater than or equal to 0. So the domain of function g would be all values of x greater than or even equal to 1. But the question you might ask yourself is, what happens when I play with these functions and do division with them? Does that change the domain? And you'll find out, yes it does. So let's see what happens. So let's answer part A. What is f divided by g of x? Well, simply take the function f of x divided by function g of x. And you put in what they gave you. F of x is 2x plus 6. G of x is the square root of x minus 1. So this technically would be the answer. Right there. Just something divided by something. Boom. Now, I wrote this up here for you just in case you got one of those hardcore vicious professors. Remember, you're really not supposed to have a square root or a radical in the denominator. So the way you can remove a square root radical in the denominator is you do something called rationalize the fraction. So you multiply top and bottom by the square root of x minus 1. Because what's the square root of x minus 1 divided by the square root of x minus 1? It's equal to 1. Multiplying anything by 1 keeps it equivalent and you're safe. So let's do it. When you multiply fractions, it's top times top, bottom times bottom. So what's the square root of x minus 1 times square root of x minus 1? Boom, they undo each other, kill the radical, and you have x minus 1. What's 2x plus 6 times the square root of x minus 1? Just keep it that way, it's ugly enough, right? So I would actually, in my class, give you full credit for this, but just in case, be prepared for all your professors out there. Now let's go to the second part, find the domain. Again, what are the golden rules of the domain? Thou shalt not divide by 0. Of course, unless you're Chuck Norris, so hi Chuck, how you doing? Or do not have a negative under your square root. So, if we look at what we came up with here, it looks like we have the square root on the denominator. Now that's interesting. We have the square root on the denominator. So what do I know about the square root of x minus 1? What's it not allowed to be equal to? Correct. It's not allowed to be equal to 0. What x value would cause havoc to make it equal to 0? Yeah, x equals 1. So we know the answer cannot be equal to 1. We also know that it has to be positive under this square root sign. So we take whatever's here. So imagine going, oh, hi, x minus 1. It's got to be greater than 0 in this case. It can't equal 0, or you'd be dividing by 0. So I got to get x alone, so I add plus 1 to both sides. What I do to the left, I do to the right. You get x is greater than 1. Now, sometimes people forget, are those the good x's? Are those the valid x's? The answer is yes. These are the good ones. They're the domain. So the answer domain in set notation is the set of all x. This forward line means such that x is greater than 1. This is set notation, solution set notation. Or you can say 1 comma infinity, basically anything bigger than 1. This is interval notation. So I hope this helps you out with algebra functions and make you feel more comfortable with notation. Keep following the Bridge for Math. We'll probably do composition of functions next. So take care and have a great one now.